Hi everyone. Hopefully by now you've read Chapter 3 and it talks a little bit about VPNs and security tokens, and it gives you a basic idea of what they are, but I want to expand that knowledge and give you a deeper understanding of VPNs and security tokens. And a lot of this lecture is going to draw on the knowledge you gained last semester in your networking class, so we're going to put that networking knowledge to use today. VPNs used to only belong to banks and healthcare organizations as secure ways to move data over the open internet, but we see now VPNs being offered to the public. If you've seen the commercial for NordVPN, for example, it's the same VPN, same technology. It's just being offered to the public so they can secure their transactions. So let's talk about what a VPN is. Here's a quick overview. VPN stands for Virtual Private Network. Virtual private networks are point-to-point connections across a private or public network, such as the internet. A VPN client uses special TCP/IP-based protocols called tunneling protocols to make a virtual call to a virtual port on a VPN server. Notice that is all virtual, right? It's a virtual private network, virtual call, virtual port. It's an entirely virtualized environment. In a typical VPN deployment, a client initiates a virtual point-to-point connection to a remote access server over the internet. The remote access server answers the call, authenticates the caller, transfers data between the VPN client and the organization's private network. So for us, there are two types of VPNs that are used with PACS. They are the remote access VPN and SitetoSite VPN. The remote access VPN allows remote access to PACS for vendors and PACS admins working from home. It's a dial-in VPN. The site-to-site VPN is set up between two facilities for the purpose of transferring studies from one place to the other. For example, Hack General Hospital might have a site-to-site VPN connection with Lancaster General Hospital to promote easy transfer of radiology studies between the Hack AGFA PACS system and LGH's McKesson PACS system. So that is data is going back and forth both ways between the two entities. Site-to-site VPN is transferred back and forth both ways. You need a separate VPN for each facility you connect with. So if Hack General Hospital has a VPN to LGH, they may also have a VPN to CHOP, to Carlisle. There should be a whole spider web of VPN connections to every different possible hospital that we want to routinely connect with. So the remote access VPN. The remote access VPN connections enables users working at home or on the road to access a server on a private network using the infrastructure provided by a public network such as the internet. So you're going from one private network to another private network, but you're going over a public network, like the internet. From the user's perspective, the VPN is a point-to-point connection between the computer and an organization server. The exact infrastructure of the shared or public network is irrelevant because it appears logically as if the data is sent over a dedicated private link. In simple terms, if you have a remote connection from your home to your hospital, once that connection is made, it's just like working on the hospital network. It's just like being at your office in the hospital. You don't notice any difference because you're now linked inside that private network. Site-to-site VPN connections, also known as router-to-router VPN connections, enable organizations to have routed connections between separate offices or with other organizations over a public network while helping to maintain secure communications. A routed VPN connection across the internet logically operates as a dedicated WAN link. When networks are connected over the internet, as shown in the following figure, a router forwards packets to another router across the VPN connection. To the routers, the VPN connection operates as a data link layer link. So there's the test of your network knowledge. Hopefully you understand all 7 layers of the OSI model after your networking class. So here it is. So you have on the left side your secure network. This is your secure network. It's not open to the public. This is maybe your hospital network. And here is another secure network. Maybe it's another hospital, right? So you're going to make a connection and send information over this open network, the common internet that we all use. What's going to happen is that VPN is going to create a tunnel inside the open internet. And so it's going to use that tunnel. Your data will travel inside that tunnel from one secure network to the other secure network, and the bad people that live on the open internet won't be able to see your data because it's secured inside that tunnel. So VPNs use tunnels. Tunneling is a method of using a network infrastructure to transfer data from one network over another network. The data or payload to be transferred can be the frames or packets of another protocol. Instead of sending a frame as it is produced by the originating node, the tunneling protocol encapsulates the frame in an additional header. It's just like when you put up something precious in a package and mail it, right? It's safe inside that box. Nobody knows what's in your box when you send it through the mail. The additional header provides routing information so the encapsulated payload can traverse the intermediate network, right? So it's got an address label on the outside of the box. So it knows where to go, but you can't see the contents of what's in the box. The encapsulated packets are then routed between tunnel endpoints over the network. The logical path through which the encapsulated packets travel through the network is called a tunnel. After the encapsulated frames reach their destination on the network, the frame is de-encapsulated, the header is removed, and the payload is forwarded to its final destination. Tunneling includes this entire process: encapsulation, transmission, and de-encapsulation of the packets. Let's use an Amazon delivery, right? If I order something for you from Amazon, it's going to come in an Amazon box with the stuff inside it. And because you didn't order it, you don't know what it is. Nobody knows what's inside the Amazon box except me and the encapsulation person who put it in the box. And the transmission is going to go through the standard mail, and then you will provide the de-encapsulation of the packet by opening the Amazon envelope or Amazon box and getting out whatever I sent you. That's basically how a VPN works. It puts all of your data inside a container, uses the standard mail or the standard internet to move it to a different place, and then the person or the system at the end will take it out of the box and see what it is. And so here's a picture of your payload. It comes to a waypoint, right? If I send you something from Hawaii, it's going to travel through several mail stations. It's not going to go directly from my house to your house. It's going to travel through stations. So here's a station right here, and your payload is inside the box, inside the tunnel, and it comes to another station and it continues on its travels. So the tunnels have endpoints in the same way that mail stations, make up a chain of mail delivery. But your stuff stays inside the tunnel, inside the box. It's very secure. Tokens, a security token, sometimes called a hardware token, authentication token, USB token, cryptographic token, software token, virtual token, or key fob, may be a physical device that an authorized user of computer services is given to ease authentication. Tokens are commonly issued to PAX admins for use with a remote access VPN to securely connect to the PAX system. Security tokens provide an extra level of assurance through a method known as two-factor authentication. The user has a personal identification number which authorizes them as the owner of that particular device. The device then displays a number which uniquely identifies the user to the service, allowing them to log in. The identification number for each user is changed frequently, usually every minute. Okay, so in simple English, two-factor authentication is what I have and what I know, right? So a user has a PIN number, personal identification number. That's what I know. The token, which looks like this, has a number that comes up every minute. So that's what I have. I have this token and I know a PIN number. That's two-factor authentication. It's what I have and what I know. So I put in my PIN and then I put in the identification number that comes up on the fob, and boom, that lets me in. Unlike a password, a security token is a physical object. A key fob, for example, is practical and easy to carry and thus easy for the user to protect, even if the key fob falls into the wrong hands. However, it can't be used to gain access because the PIN, which only the rightful user has, is what's needed. Again, it's what I have and what I know. That's why it's two-factor authentication. So, think about this. Connecting remotely is not easy at 3 a.m. You are the PAX admin on call. Your phone goes off at 3 a.m. After talking to the caller, you need to connect to the PAX system. So step one, you're going to need to log into your home PC or laptop. Hopefully your home PC is relatively secure. It has a password on it. Then you're going to need to start up the VPN. To connect it, you need your VPN username, your VPN password or PIN, and the numbers off the token, which cycle every minute. Once the VPN connects, you'll have to start PAX and log into the PAX. You may need to log into a PAX server, which will have a separate username and password. So think about that. Just run through all of those steps. How many logins and passwords did you need to know at 3 a.m.? I used to keep a little book at home, never left home, stayed in my dresser drawer next to my bed with all of the different usernames and passwords I would need to know, because at 3 a.m., I'm just not that good. Thank you for watching.